正在连接。开始连接话筒。已解锁，请取出话筒。
Hello, testing. All right. Can we start? Any questions you want me to start with? No. You okay? Everything in the lecture. I follow. How's your revision? Assignment? What assignment? Oh, that's not bad. Okay. How about the rest? Have you tried these questions yet? Revision set? If not, maybe you can spend uh, maybe half an hour now, starting now. You can do any question you like. You can run through the question set. So there are chapter 5, chapter 6, chapter 7, and then chapter 8. You don't need to do one by one, but just do at least one from each session. And then if you don't have an idea, then we should discuss here together. So to check what concept you are missing. Okay, yeah. Or just do whatever you like first. Yeah. Maybe you can try half an hour, do this question. And then we can pick a few questions to discuss. I mean, you could start with the most unfamiliar one first. Yeah, so we try to spend half an hour looking through this question set here. You can discuss with your friends and then see which concept you are most familiar with or you want us to discuss in the class. Do it. And, okay, maybe in 30 minutes time, we'll try and discuss some questions from chapter 5. So if you think that there's some particular question that you cannot do, we can discuss together. Maybe we can start with chapter 5. In chapter 5, there's one question I want to discuss. Perhaps it's question 1. Because this is a kind of a concept question, not the usual calculation question. It's about Riemann sum. Estimate the area of the region bounded by the curves y equals to x cubed minus 5x squared plus 6x plus 5, and also the line. So I guess you can use a graphing calculator to help you to graph it, but we assume it's positive, always positive here. And line x equals 0, particular line x equals 0, and then the line x equals 4, and also the x-axis. So actually it's this region here. Okay. So we're going to find the area under the region, okay, using 8 rectangle with the left endpoint evaluation and the right endpoint evaluation. So one is about left, one is about right. So what's the rectangle here? Well, you just care about the rectangle that's equally distributed. Okay, so for example, you set delta x, which is the width of rectangle, to be 4 minus 0 over 8, equally distributed. And so you add by half, 1, then 1.5, then 2, 2.5, 3, 3.5, like that. Okay. And what's the height? So the height here depends on which endpoint you're gonna take. Okay, so you form a rectangle like this, right? And so if it's left evaluation, so you take the left endpoint to build your rectangle. Okay, so in this case here, you have like x1 equals 0, x2 equals to half, right? x3, blah blah blah, 2. Sorry, do we start with 0 or start with 1? Let's start with 1 is fine. X9 equals 24. So you have this estimated area to be equals to, so you have the first, so how many rectangles you have? So let's label them. R1, R2, R3, R6, R7, and R8. So you have 8 rectangles to add up. Okay. We know all their width are just half, but what's their height? Their height is taken to be the left endpoint. Okay, so you pick the left point to evaluate. So for example, for R1, right? So we'll take x1 equals 0. And then for R2, we'll take x2, and so on. Okay, so what's this f? Maybe let let fx equals to y. So we just take the height. So we have a half of 0 plus 5 plus half of So you need to evaluate it. So like half cube minus 5 half square plus 6 half plus 5 like that. This this function is a bit long to evaluate. Maybe I will leave it to you to figure out what is it. Can you get the idea? Can you get the idea? Yeah, so you need to do for like 8 terms. Okay. You need to substitute. What are the numbers you need to substitute to the function? Get the height. You need to substitute 0, half, 1, 1.5, 2, 2.5, 3, 3.5. Okay, we use the left one. Does that make sense? Yeah. I don't know what's this answer, but you can continue to do it. But so you have seen left endpoint evaluation, right? How about right endpoint? So how about if you choose right endpoint, meaning what? Which height you gonna consider? Which height you gonna consider? Hmm? So you look at this rectangle again, right? R1. Okay. So left endpoint is 0. So right endpoint should be half. Okay. So you should look at the height of your half. So for example, should look at this one, the right endpoint. Yeah. Okay. So instead of taking x1, fx2, you start with f. So for maybe for this is for part A. So for part B, your estimated area will become half of fx2 plus half of fx3, and then all the way up to fx9. Did you see the shift? The first set we use S1 to S8. The other one we use S2 to 9 because we choose the right endpoint here. Does it make sense? No question? This question is very important. We're gonna have this kind of question. So does it anyone can't follow? Do you have any question? Please ask now. Don't ask during the exam. I see left, right. Please ask now. Yes. Confused. Yeah. The B or the A? Okay. How do you confuse? Differently? Left and right. Okay. So to check about this left and right, right? So you need to figure out your rectangle first. Okay. Figure out the 8 rectangle. And then inside this rectangle, right, there is each rectangle, there's a left and right end for your width. Okay. So picking this different endpoint will give you different height of this rectangle. So for example, if you pick the left endpoint here, you evaluate the height. So this is the point. Yeah. But if you choose the right endpoint, half, and then you try and evaluate the height, is different. So picking left and right, there's a difference. Does it make sense? Yeah. Okay. So left and right, there's a difference. So you need to be careful. Well, yeah. So left evaluation meaning for every rectangle, you should pick the left endpoint. And then right endpoint evaluation is for every rectangle, you should pick the right endpoint. That's it. But in theory, right, Riemann sum doesn't care actually. Yeah, Riemann sum can take any point in between. left and right. I mean, well, this has to be done with taking limit of the width of rectangle going to 0. But even here, it's just estimation. It's not the exact um, exact area. But we know how to find this exact area, right? We can do the definite interval. Okay, any question on this? I guess all the other questions are calculation, but this is that noise the top. If this question come out, you can do or not? Actually, you can do it. Okay, please ask. Okay, how about other question? You want me to go through or not? Any seemingly hard question that you think that I cannot do? I cannot do, then we can do together. Got or not, Alicia? Anyone want to choose a question we can do together? Huh? You okay? You want to try? Which question should we try? I no? Yeah. Yep. Which one? Which one? Do you have specific question here? Let's start with some specific question. Three, number three. Let's see. These two, both of these? Both, Mm. Sure. So first one, you integrate x times e to the x square, okay, from minus 2 to 2. The other one, we do e to the x4, 2 times e to the x4 sine x5 plus x squared dx. Okay, so you see that there is a friends there. I mean, they are friends together. So what do I mean by friends together here? A function with x derivatives are friends. If you see a function with its derivative appear together, they are friends. And why are they friends? Because we can use substitution. Okay, did you see friends or not? X squared and x, are they friends? X derivative of x squared is what? 2x. So you just need to divide by 2, you get x already. And then the other one is x to the power 5. So what's the friends of x to the power 5? 5 times x to the power 4. Okay, x to the power 4 is there. 5 we can easily I mean like multiply by a scalar. Okay, maybe we can try and do these two quickly. Okay, I mean like first thing you should try is substitution, right? Very easy technique, so we should try it. So let's say b equals to x squared, and then dv equals to 2x dx. Okay, so you can see that both of these factors appear. Okay. Um, right. So we should do substitution. So remember, when you do substitution, your integration limit also need to change, right? So when x equals to minus 2, v is 4. When x equals to 2, v is again 4. Huh? This is very dangerous. So evaluate 1 point is only 0. Did we miss anything here? I think this question is 0. This question should be 0. Yeah, evaluate 0. You also get 0? Odd function. Oh, wait, let me see. Oh, cool. Yeah. Good. This is an odd function as well. So actually it's 0. Okay, let's finish it first, and then we will discuss why this guy is 0. Okay, uh, so this is integrating from 4 to 4, and then this is e to the, what is this? E to the v, and then divide by 2 dv. But this is easy. It's just half ev again. From 4 to 4, you get 0. Okay. So there are a few ways to see this guy is 0. So whenever you are integrating along just a point, you always get 0. Okay. So you can imagine that the line is too thin and there's no area for the line. Okay, 0. And the second way is like how Vincent says, x times e to the x squared is odd. Why is it odd? Right? E to the x squared is even, right? Because x squared minus x to the square also x squared. So it's even, but x is odd. Okay? And then this region is from -2 to 2. Huh? So it's symmetric about the 0. So if you integrate an odd function symmetric about the 0, it is 0. Okay? So the idea of odd function is like this. If you are symmetry around 0, the positive and negative function area will cancel. Okay. So, well, maybe let me write like this. X e to the x squared is odd, cos minus x e to the minus x squared is equal to minus of the original function x. Okay. So integrating an odd function across 0 is 0. Function of, okay. So far so good. Okay, so given this question, right, can Felicia think about how B can be solved? You try how B can be solved. You got friends there or not? And yeah. Substitution, yeah, yeah. But I think for this question, substitution is not enough because the E is beside the sign. So I think you need to use by part. Yeah. But this term here, please don't combine them together. I think you separate them. Okay. Yeah. Don't do substitution on this guy also. This is just a simple integration. S cubed over 3 and then evaluate it. Okay. But this term here, I think you need to do substitution and then integration by part. Can you imagine what I said? Yeah. So I think you need to like differentiate sign or integrate sign, then you get cos, and then you get back your sign, then you can compute this term. Like what we're doing. Okay. Question? Any question? A question? Please ask now. This is the moment that you can ask. This is the moment to learn. Okay, any question from chapter 5 before the next hour? Maybe we can go to different chapter. 6, 7, 8. Any more questions from chapter 5? About maybe chapter 6 we can do later because 6 is quite long. Chapter 5. About Javed, did you try any of them? Chapter 5. Do you think any question that I gave you is you definitely cannot do one? Then we'll do it now. Can you try have a look? Yeah, you look at it. First, I have no idea. Okay, we do it now. Yeah, try and pick one. Yeah, which one you want to pick before we take a break? You can see from your revision sheet, right? It's yeah, pick one. We can do together. 9B. 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 Okay. Evaluate the following integral if possible. If it is not possible, clearly explain why it is not possible to evaluate the integral. So we want to do 5B. So this question. So this is a double angle formula here. Okay, not double angle formula, but double angle triangle. 8 cos 2x over square root of 9 minus 5 sine 2x. Integrate from 0 to power 4. Okay, so you can see that there's no square inside your square root, right? But moreover, there's a sign inside there. What could we try? Substitution? What kind of substitution? Let Maybe we can try. Look, we just try. We just try. Okay, see how it works. So let u equals to the whole square root thing, just the thing inside the square root. Okay, how this could help? How could this help? So you differentiate this guy, right? So you have a chain rule that appears, right? So you should have a minus 10 like this. Okay. Oh, so meaning you found the friends. Ah, did you see the derivative appearing in the numerator? Did you see? No, no, no see. So you see here is negative 10 cos 2x, right? But here 8 cos 2x. It's not far away already. If it is differ by a constant, right, we can easily change the constant. Okay, so this function is very important. Cos 2x is appearing. Okay, so we can rewrite this because du over 10 equals to cos 2x dx, like that. Okay, so you can see that this term get combined. Okay, so well, we are doing change substitution, right? So let's change the limit. When x equals 0, u equals to 9. When x equals to pi over 4, u will be 9 minus 5 times sine of pi over 2. So pi over 2 is 1. So here is 4. Right. So our integral will change from something in x to something in u. So we still keep this 8, but gonna divide by minus 10, 1 over square root u. So let's get the constant out. Minus 4 over 5 u to the minus half du. So this one we get plus 1 divided by half, 2 times u half, 4 to 9. Maybe we can pull the 2 out again. So square root 4 minus square root 9. So altogether we get 8 over 5. Okay. Yeah. Javed, what do you think? Any question? Can follow? Okay. Yeah. Okay, Anna. Happy? Happy? Okay. Okay. So maybe after break we will come back with question chapter 6, 7, and 8. Okay. 7, 6, 7, 8. Please choose some question. We'll discuss together. Okay, after break. So let's return at 10:04.
our final our song like time with mine.
Yeah.
So now he needs like in the third like
Uh, Focus is on 5 to 9. Yeah. Yeah, focus is on 5 to 9. I cannot say exactly no derivative, right? Because, for example, chapter 9, there's derivative there. So I cannot say, but the focus, yeah. Hmm. I mean, you cannot just forget it, right? Does it make sense or not? Maybe inside the calculation you might use it, I don't know. But you cannot like exactly forget about it, right? This is impossible, you know. Like, can you say like, oh, because this is just integration, I forget about kindergarten. I don't know how to read 1, 2, 3. Yeah, lah. Not like that, right? So I can just say that the focus is on 5 to 9. Does it make sense? Does it make sense? Yeah. Mm, okay. Yeah, whatever related to 5, 6, 5, 6, 7, 8, 9, you should. Yeah. I think there are 5 of the group haven't hand in your video yet. You haven't. Okay. So if you don't put on YouTube or somewhere, I put a link for you, right? I invited your leaders to the SM drive, so you can upload there, and then you just provide the link there. If you put on YouTube also can. But if can, you upload your file into the SM drive. I invite all the leaders into the group already. Okay, I think we have to pick one question from chapter 6, number 2, and number 3 to try. Okay, maybe you can pick the hardest one and we can do it together. Yeah. Which one do you think you have no idea? Or it seems very intimidating? Then we will settle that question. Maybe this time round we get the 日本 to pick one. Can it be? Ah, 什么 pick one. Who? Which one? A, B, C, D. C, ah. Okay, let's try C. Okay, so let's bring this question out. Okay, using the method of this washer, this washer, this or washer, this method or the washer method, to determine the volume of solid obtained by rotating the region by the given curves about the given line. So let's try see. Do you still remember what's the method of this means? So this looks like this. Okay. And then washer, how about washer? So washer, you can think of it like a hollow disk because you need to put your laundry into it, right? Sure. Okay, so let's draw this picture. See whether you need a hollow disk or this punctured disk, not hollow disk. All right, so what's this curve here? Y equals to 6 times e to the minus x. Okay, how to plot this? E to the x looks something like this, right? So e to the minus x will be flip the function across the y-axis. Okay, this is y equals to 6 times e to the minus x. And then how about 6 plus 4x minus 2x squared? Okay, so this, how does this function looks like? Well, we can try and rewrite this function. This is a quadratic, right? See if you can get the roots or not. So if I factorize this, we'll get minus 2 of square minus 2x plus 3. And what can we see here? Actually, we can find the roots, right? It is x. Oh, can we? We can't. Or we cannot. Yeah, actually we cannot. But we cannot find the roots. What does this mean? This have no real root. Because b squared minus 4ac is minus 2 the square minus 4 3 is negative 10, no real root. Okay, but if it is x squared, I guess it's going upward, right? But now it is should be going downward. How to graph this guy? Let me think about it. Oh, I think I make a mistake, right? Otherwise, I think it cannot bounce stuff. So did you see I made a mistake here? So if I put a -2 out there, become positive, right, for x squared, the coefficient. And then the coefficient for x become negative. But here I forget put a negative sign here because plus minus is minus. So here should be a minus sign. Then I think this one is good. So actually this is -2 times x minus 3 times x plus 1. Okay, so what does this mean here? So if you just look at this quadratic x squared minus 2x minus 3 has a real root at 3 and then another with -1. Okay, so it looks something like this. But now you take a negative of it, right? So it is facing down. So it's facing down. Okay, but there are some issue here, huh? There's some issue you need to take care here. Where does it like going down? Okay, does it intersect y axis as the same point as the other function or lower or the higher, right? You need to figure this out. Does it make sense? Okay. Yeah. So how to figure this out? It's very straightforward, right? You just substitute x equals 0. What is your first y here? Maybe name this y1, this is y2, y1 and y2. Okay, so let's look at what's y1. y1 is e to the -2 times 0, which is 6. Okay, so this point here is 6. How about y2? y2 is also 6. Okay, very good. They pass by the same point. Okay, so we are safely draw this graph like this. Okay. Next is it asks you to integrate between the region of these two curves and then find your x equals 0 or this point here, and then x equals 1 is about y equals to -2. Right. Yeah. Okay. Yeah, should we check what are these 2 points here to make sure what we are doing? So let's say when x equals to 1, y1 is e 6 times e to the -2. So this is 6 times e to the -2. And then y2 will be 6 plus 4 minus 2, which is 8. Yeah, so this point is 8. Okay, so you take this piece here and then you rotate around y equals to -2. Okay, so far so good. So you rotate like that. So on the other side, you should have something here as well that you rotate. Okay, so did you see this solid here? There's something hollow inside it. I mean, there's some emptiness, right, in the middle. Okay, there's some emptiness here. Okay, did you see the washer here? Or your washer looks something like this. Hmm. Should I use another color to differentiate? Use purple. Okay, so to use the washer method, what do you need to determine? Do you still remember? At least I forgot. Okay, so if you forgot what to do, go to your notes. Okay, go and find what's the washer formula. Okay, what's the washer formula here? pi of maybe this is okay. So what do you need to determine if you want to use a washer method here? You need to get what's the R out and R in. Okay, R out and R in. So after you get the R out and R in, what do? You take the area of the circle of the outer circle minus the area of the inner circle. And then integrate along on the other direction of your radius. Okay, so what's our radius here? Where's the R out? So from this picture here, right, we can see that the R out is y2, okay, and then R in is y1. Why is there this color? Maybe use the black one. So if you pick from the middle point here, R out is y2, and then R in is y1. So to be consistent, maybe you can use this kind of argument. If you want to determine what's the washer, make sure you need to determine what's R out and R in. Okay. So you can say that it is a washer with R out equals to the quadratic function and R in to be the exponential function. Okay. And then what's the formula? Such that the cross sectional area, okay, in terms of y is pi of r square out. So 6 plus 4x minus 2x square minus 6 to the 6 times e to the 2x square, like that. Correct? Yeah. Okay. Then what about the volume? Okay. So this is in terms of shouldn't in terms of y, right? It's in terms of x. Okay. So because your radius is in the y direction, so you need to integrate along the other direction. So how about with volume? So volume will be integrating from where to where, looking at the question here. From x equals to 0 to x equals to 1. So from 0 to 1 of this ax here, dx. Okay, I didn't compute the area, but you know how to continue from here? Okay, Yihan, what do you think? Do you think? Okay, so you integrate from 0 to 1 on all these pieces of disk. Okay. Washer. In this case, it's washer because it's a punctured disk. There's a hole in the disk. So you integrate along this washer. Yeah. Any question? Ethan? Okay. Is this what you think? How about the rest? Can follow? Yeah, feel free to ask. Feel free to ask. Okay. Should we do one more for this cylinder? Not cylinder one. How about Jiachen? No? Pick one. If you don't have question, maybe you can teach us how to do. Fourth one? Okay. Let's try the fourth one. So now we're going to use cylinder. So the shape of cylinder will be looking like this now. Okay. Just now it's just like a disc. Now it's a cylinder. So let's see how we fit the cylinder into the volume of solid. Well, again, we have to draw the picture first. Okay, let's draw a picture first. X equals to y squared minus 4. So this is a little bit tricky because it changed the direction. Right? Usually you'll see like y equals to x squared minus 4. But the difference here is just you rotate the rotate your hyperbola. Okay. So which direction you should get here? X equals to y squared minus 4. Or in other words, x squared equals to x plus 4. Is this easy to see? Or maybe, okay, y squared is always positive, right? Okay, it's always positive. The lowest point of y squared is what? 0. It's 0. But now this point can get to minus 4. Okay, so, okay. Okay, in other words, x equals to y squared is looking something like this. Okay, why? Because y squared is always positive. So your s is always positive. But now you are taking minus 4. So you move the x down to minus 4. Okay, looking something like this. How about x equals to 2 minus 3y? I think this one is relatively easier. Right? So if you move these around, you get my y equals to x over 3 plus 6 like that. Okay, so this is just some linear line. Did I get the sign wrong? I think I get the sign wrong. Did I get the sign wrong? No, right? Okay, I did. So you should get minus 3 over x over 3 plus 6. Okay, so then we change the other direction. Okay, so far correct or not? Yeah. No, sorry. This one need to divide by 3, so I get 2. Okay, so you shift up by 2, so this one shift up. Okay, again, there's a problem here, right? I'm not sure whether they intersect at the same left or y intersect or not, but we can compute it, right? Certainly. So when x equals 0, 0 equals to y squared minus 4, y equals to 2 and minus 2. So here is minus 2, here is 2. Similarly for the other cases. So let's name this y1, this is y2. Should I do this? Yeah, sure. Okay. So if it is y2, then y2 also equals to 2. Okay. So meaning actually they intersect at the same point. So rotate the region bounded by these two curves about the line y equals to minus 2. Okay, good. So actually it's this large part here. And then rotate around y equals to -8. Right. How to draw this rectangle, sorry, cylinder? Yeah. I think it's a very similar shape of like what we had just now. Y equals to -8. So you will get something like this. Around now. And so you rotate. Yeah. So what's the cylinder here? Did I get the shape wrong? Is it okay? Everyone agree with this shape? Agree with this shape? I think I'm right. So how to set up this cylinder? I also forgot. So I go to the notes and then find what cylinder is. Cylindrical. Okay. So what do we need to set up the cylinder? Okay, so what we need was we need a radius of the cylinder, we need a circumference of the cylinder, we need the height of the cylinder. Okay, there's a lot of things we need. But can we fit the cylinder into our solid or not? Okay, can you imagine our shape get split into cylinder or not? Huh? Can you think of this as a cylinder? Okay. So maybe I use a black color. So how your cylinder looks like? So your cylinder maybe looks something like this. And then, so maybe let's draw a cylinder around here. Okay. I think this is not a good example. Maybe I can draw here. Maybe draw around here. Okay. Cylinder. Okay. So can you see that if you look at the cylinder built below the linear line, right? Okay. It's going infinite, but we want it to stop at the lower bound of this x square here. Can you see it? Can see? This part, the shaded part, we don't want. Okay. This is a bit like your quiz question. Huh? You take the top curve minus the lower curve. Can see? Can see? Okay. So, okay. So let's write down. So where's your radius? So your radius is counting from -8 up to this point here. So your radius, so the cylindrical shell has radius um x plus 8. Is it plus 8? because you're gonna integrate from -8 to 2. Okay. X plus 8. So where this x we're going from, sorry, it's not x off, it's in the y direction. So your radius is in the y direction from -8 to 2. Okay. Correct or not? Does it make sense? Plus 8, only then your radius will come from 0. Okay. And then the problem is your circumference. So circumference is very easy once you have your circumference. Your radius is just 2 pi of your radius. But the height here is a problem. Okay, so what's the height here? So you should take the upper bound. So your upper bound is this. So your upper bound is y2, which is 6 minus 3y, and then minus the lower bound. Your lower bound is y squared minus 4. Okay? So this is your 6 minus 3y minus y squared plus 4. So meaning plus 10. Okay? Is it okay so far? Then, how do you set out your the integral here? So the integral here is just your circumference times your height. That's it. Okay, so volume will be equals to integrate from -8 to 2 of your circumference multiplied by your height. Okay. Yeah, any questions so far? Any question? Let me see. Is your radius correct or not? I think our radius is too big. I think our radius is too big because we start all the way from here. There's something here, so which is not good. I think we only start with this point here, right? So what's this point here? So I think we need to find what's their intersection. We are just integrating, sorry. So our radius, I think we just integrate from this part to this part. It's not all the way to -8. Okay. So I think we need to find what's the intersection point here. Okay, let's try and see if we can find this intersection. So find intersection point between x equals to y squared minus 4 and x equals to 6 minus 3y. Okay, so let's quickly do it. Consider y squared minus 4 equals to 6 minus 3y. Then we get 6 squared plus 3y minus 10, 0, which we get y minus 5, y multiply, and then y minus 2 equals 0. Okay, so one of them is 2, the other is -5. So meaning this point is -5. Okay, So I guess our radius just need to care about starting from -5. No need from -8. Okay. Yeah. Okay, so our height is considering from -5 to 2. That's it. No, our radius, sorry. Okay, so meaning our cylinder is all these cylinder here. Our cylinder only in this region. Going down. And then anything below this hyperbola here, we don't want. Okay, so your cylinder will focus on this area. Okay, question? Please ask now. Okay, yeah. Jiachen, how about Jiachen? You think makes sense? Okay. Yeah, if don't make sense, you can always ask. Hey, where's Margaret? Didn't see Margaret today. Where's Margaret? Don't know. Yeah, Javed, okay, Javed. Can follow? So try to start from scratch, see if you get the same thing. Okay, so let's go to chapter 7. Is chapter 7 okay or not? Is it straightforward? Maybe some of them are tricky. Maybe from 1, 2, 3 can pick 1 or 2 questions. Yeah. Yeah, who haven't picked yet? 说相似. What do you think? Anything you are not confident with? Everything? No, it's okay. Since they are everything, right? So now I let you pick one first. Yeah. Have a look on this. Try pick one. Huh? Yeah, pick one. Okay. Second, which one? First A, yeah. Okay. So let's look at A. Square root x squared plus 16 over x plus 4 dx. Okay. So now this question very straightforward, right? It asks you to use trigo substitution. So well, you then you go to the trigo section. Have a look. Trigo. There's a table, right? Did you still remember? There's a table that we suggest you what to substitute. So go and find that table. Okay, yeah. Okay. So our expression is all positive. So meaning I think we should use this tangent substitution here. We could try with this tangent substitution. So in this case here, let x equals to a tangent square. So the a here is the square root of 16. Like that. Okay, and then what we do was this integral here will be turned into square root of 16 tangent squared theta 16 over 4 to the power 4 and then tangent to the power 4 theta. And then what's this trigo identity here? Tangent square theta plus 1. Anyone know? Second. Is it second? So this started with sine square theta plus cos square theta equals to 1, right? So you need to create this tangent, so meaning you divide everything by cos theta. Okay, so you already get secant square theta. Okay, so actually you get secant theta after taking square root over 4 to the power 4 tangent 4. Okay, so how do you deal with secant theta and tangent theta? I think you need to know the relation between them, right? Like what's their derivative, for example. What derivative do you know about? So I guess, let me see. Did we record any useful derivative here? So let's go to the derivative section. Now, this is what I say. You see, so although we are focused on chapter 5, 6, 7, 8, right, we still need to go back, for example, like um, chapter, let's see, chapter, chapter 3, okay, to learn about the derivative. So I cannot say that, oh, don't look at derivative anymore. Okay, it does, the knowledge doesn't work like that, right? Okay, so look at here. Okay, does this derivative help? If you want to substitute tangent x, right, you need a secant square x. If you substitute secant x, you need a secant tangent. Uh-huh. Yeah, any idea? Sorry? Rewrite tangent. Let me think. How should we rewrite tangent? Oh, you break it down? Okay. So let's see. So rewrite it. So meaning, let's say this, I also write it as cos theta, then we have sine theta 4 theta over cos square 4. Like that. And so you cancel out one of it. Three of them become cos to the 3 theta over sine the 4 theta. Okay, I think we write it too close, so. And then what can we do with this? Substitution. You mean u equals to sine theta, and then du equals to cos theta d theta. Okay. So let's see why it works. I mean, we just try and error first. So we get u to the 4 at the bottom. At the top, one of the cos theta will be absorbed to give you du, but you still have cos square theta. Okay, so you can use this u equal to sine theta to transform this again to 1, let me think, cos square. So 1 minus u square, right? Okay, and then this will become very easy integration now, which is u to the minus 4, and then the other one is u to the minus 2, which is u to the minus 3 over minus 3 minus u to the minus 1 over minus 1 plus c. And then you remember to sub your u back. What's your u? Sine theta. So maybe did I get the sign wrong? No, right? Again, theta is not enough because we do another substitution, so you need to substitute all the way back. So you get 3 of sine cube theta, which is what? Long, which is tangent inverse of x over 4, like that, plus 1 over sine of tangent inverse of x over 4, like that. Okay. Okay. 这样子 okay. So I think we did 2 substitution for this case. Has a plus c. Please don't forget the plus c. I think in this quiz we deducted mark for plus c if you don't do it. Yes. Say again. Repeat again. Mm. Mm. 4, yeah. Why there's no 4 in front of the second? Oh, I think you are right. There's a 4. So we reduce by one power here. So here we can just 3. Is this what you mean? Yeah. Okay. Yeah. Yes. So there's a 4. Correct. Yeah. Okay. Any more for question 7? Maybe pick one from question 4 here. Pick one from here. Who want to do it? Maybe one from Gabriel or Jeffrey. Jeffrey or Gabriel. Yeah, either one of you. Yeah, pick one question from chapter 4. No, question 4. Yeah. D. 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 Dog, D for dog. Okay. So determine if the following integral converge or diverge. Okay, if it converge, determine its value. Okay, so if you look at this question here, right? Why is this question even categorized in this improper integral here? Because did you realize that there's a point that where this denominator doesn't define? It is when x equals to square root 2. Okay, but if you look at this integral, right, this is going from 1 to 2. So inside there, there's a square root 2. Okay, so you should split your limit up there. Okay, right. So still remember, how do we split the limit up? So this limit will be defined only if these two number here, this two number here make sense. So you need to go from square root 2 from the minus part. And then also from the positive part. Okay. Only when these two converges, okay, then only when these two converges, the original integral converge. Okay, converges. But can you compute this integral or not? This integral. I think substitution rule will work. Yeah, this substitution will work. So let's compute this first. Okay, where we let y goes to x squared minus x, dy goes to 2x dx. Then this will just become 2 times dy over cube root of y, which is what? 2 times 3 over 2 to the y of 2 over 3 plus c, which is 3 times x squared minus 2 and 2 over 3. Like that. Okay. So far, okay. It's fine. Okay. I mean, first strategy you should try is substitution. If substitution doesn't work, maybe by part. By part doesn't work, maybe other trigger substitution. Okay. Then you put it back in, you get 3 times x. Okay. I think we should write down the limit first. Plus c, we just ignore it because later plus c minus c, you get 0 also. Okay. And then this will turn to chapter 1 question. Right. This is a chapter 1 question. So if you forget chapter 1, how to do this? I don't know. So you cannot just ignore chapter 1, right? We're gonna use chapter 1 technique here. Okay. So we can see that b squared minus 4 to the power 2 over 3 is continuous at square root 2. So this term here and this term here should go to 0. Okay, so what we left with is minus 3 minus 1 to the power 2. So you get minus 3. The other one, 4, 3 times 4 minus 2 is 2 to the power 2 and then take cube root. I think you cannot compute it. I think that's all. Or maybe you can combine it a bit. So maybe is it better to write it in no any better, right? So this is the easiest form, exact form. Like this. Okay. So it converges because both of these terms converge. Okay. Yeah. Is it Jeffrey or Jeffrey? Yeah. What do you think? Can follow which step if you have any problem? Sorry, you understand? Okay. Yes. Where the root 2 come from? Where the root 2 come from? Yes, yes, exactly. If you look at this denominator, right? When you set x squared minus 2 equals 0, this is where it's undefined, right? So x cannot be equals to, so this will implies that x is equals to square root 2. So x cannot be equal to square root 2, otherwise it will give you denominator 0. Okay, maybe I should write that 4x over square cube root of x squared minus 2 is undefined at x equals to square root 2. Okay, good, good. Okay, in the next hour, we will try and finish up chapter 8 and 9, one question each. And then we'll discuss quiz 4. Okay, and then if there's more last question, we can try and ask. And after that, then we'll be off for final. Okay, let's break until 11:06. 加糖诶。Yes. Not really. You still have time to do a subtitle. Yes. Say again. Next week. Next week no more because next week is a revision week. But you can message me. Mm.
Sedikit mah ya paling cuma nambah kita beli 5% gitu pakai 40% kok. Oh ya belum biar segitu kita dekat gitu. Kan tertib sekarang yang di kelas itu yang dia di lanjut itu teksturnya nggak bisa lihat kata ya kamu walaupun jadi ya tetap ya makanya nggak terlalu gimana soalnya kan kata guruku ya itu tuh sekarang tidak di settingnya dari library jadi teksturnya nggak bisa lihat kita berapa
Masalahnya dari ini nggak banyak banget bisa
kamu yang mana ya udah 20% udah
tapi memang ya itu ada bilang pas yang tahu kita yang pas jadi itu nah itu ini dia udah kasih pengalaman sih tapi masih tapi aku nggak tahu dia aku nggak
kan yang toleransi 40 individual
tahu yang pak
oh ya 40 individual
eh
harusnya menurut itu lebih potensi ya jadi soalnya kita nggak potensi tidak misalnya berbeda itu lebih dulu dari tinggal lihat Ikutnya aja. Tidak mampu seperti itu.
Okay, let's start. I think chapter 8 are quite straightforward, right? Chapter 8. I think chapter 8, there are really two things you need to know. It's just the arc length and the surface area. And the formula are quite straightforward. So maybe you can quickly revise. I think there's no tricky part for this topic here. So for the arc length, what do you need to do? You are integrating square root of 1 plus dy over dx squared. Okay, I give you a curve and then you take the derivative, take the square, plus a 1, take a square root, and then integrate along the x you want. And then the other thing is surface area. So, okay. There's another thing called the arc length function. And basically it's the function where you integrate up to, instead of have a definite length, you integrate up to x, a certain point. That's it. You make it into function. The other one is surface area. Okay. So the surface area is 2 pi times the integral of your yx. So what's yx here? What's your yx exactly? So this yx here should be your radius. Right? No? Okay, should be your radius. Okay, should be a radius, and then you integrate along your dx. Okay, integrate along your curve. And so that's why there's a curve component coming in here. Okay. So how do you imagine this? Did I draw any picture? Yeah, so this is the picture. So you are no longer integrate along a straight curve, but maybe this curve is like curvy, very curvy. Okay. So that's why there's a line component coming in here. So you have this line component, and then this is your radius. Does it make sense? So as what are you doing is you are integrating an irregular cylinder like that. How do you compute area of a cylinder? 2 pi r times h. Okay, so r and h is something that you need to integrate along. Okay, yeah, that's it. Make sense? Shall we do this or maybe try surface area? I think length is pretty straightforward, but how about try surface area here? Which one we want to try? Maybe try number 5. Yeah, let's try number 5. How about try number 6? The hardest one. Okay, so let's find the surface area bounded by the object rotating y equals to sine 2x. So what's sine 2x? The period become, so pi over 2 become pi, right? So pi should be, pi over 2 should be taking value 1 at sine x, but then now you're taking 2 times it, become pi. So meaning your period become longer. Okay, so longer. When x is equal to 0 up to pi over 8, so pi over 8 times 2 is pi over 4. So pi over 4, where is pi over 4? Maybe we need to make it a lot bigger. So pi over 4, I guess, is somewhere here. Sine pi over 4. Sine pi over 4. even earlier than pi over 2. So maybe somewhere around here. And then such that this point is sine pi over 4. Okay. So surface area of this part rotated about the x-axis. So your x-axis like this. So here is it. That's it. Maybe I draw a bit too far. Okay. Okay. Right. So what's the formula? Let's write it down again. So the surface area equals to 2 pi of integral. So here we are integrate along the x-axis from 0 to pi over 8. Then your y is sine 2x. How about your curve component? Square root of 1 plus dy over dx squared. So you get cos 2 times cos 2x. And then square and then dx like that. Okay. Agree? Agree with this setup? Okay. Yeah. But I think this calculation is a bit tedious. You do see friends, right? Cos 2x and sine 2x here. But then I think you need I guess you need a trigo substitution here. After a substitution, you need to do a trigo substitution. Do we set up the stage for you to calculate? Maybe you let u equals to cos 2x such that du equals to minus 2 sine 2x dx. And then such that you will get do we know what is cos pi over 4? Cos 45. 1 over square root 2. Half square root 2 is it? Wait, I mean like 1 over square root 2. Is it? Cos 45. Yeah. So you get the minus 2. Yeah. So this one is a square root 1 plus. Yeah. Yeah. I think this term here you need a trigo substitution. This term. You need trigo substitution. I think it's a tangent again, right? Because this is a plus everywhere. So I guess you need to set like 2u equals to tangent theta. To solve this. Trigo substitution. Okay. Yeah, any question so far? Can I leave it to you to compute? This one is du. Okay. Is it okay? I stop here. You continue. Okay, any question so far? Any question? So I think the key thing about surface area is the radius and then your curve, the length of your curve or the height of your curve. So far, so good. Question? Any question for this part here? Okay, so we cover both the length component and the radius component for your surface area. Okay, last chapter. Okay, how about last chapter here? Last chapter. Which one should we try first? I mean, I'll let you pick. Maybe pick one from these, each of them, maybe. I think question one should be okay, right? How about question two? Maybe we can try question two because question two get you solve it, and then you need to find a constant. Okay, which one is non-trivial? Yeah? Or maybe we can just discuss everything. Everything. Yeah. Maybe we can discuss everything. I mean, we can discuss how to start. Okay, so for example, for the first one A, we can rewrite it as dy over dx times e to the minus y to be equals to 2x minus 4, right? Okay, so we can see that the variable can be split up, meaning I can move all the y to the other side, move all the x to the other side, so that I can use separable equation to solve it. Okay, happy? Yeah, no? Okay. So once you can split variable to both sides, you can use separable equation. Okay. So now actually we are doing something mm, illegal here, meaning we split out dy over dx like a fraction. Okay. But this illegal move is proven to be workable, so you can do it in this case. Please don't do it other case. Okay. Only in this chapter you can do it. Similarly, for the second part here, you can split it to dr over r squared equals to d theta over theta, and then you integrate both sides. Okay. And I think for the rest is the same. For example, part D is dv over 10 minus 2v, and then the other side is dt. Okay. And similarly for E is you have to move everything down. How about let me ask you a question. Can I write like this? Dx over 5x equals to minus 3 dt. Are they the same or not? Are they the same for E? Same. Not the same, it's very different, But then this is something that student could write down. They just move the 5x down and then they forget this minus 3 have to follow this 5x actually. Meaning you are dividing both sides with 5x minus 3. You are not like just move this out and then move down. Okay. So if you want to remove 5x, you have to remove with minus 3 because we are dividing by 5x minus 3. We are not taking away minus 5x. Okay. C, I think is quite straightforward. C, is it straightforward? C seems like a bit weird, huh? D, I think C you cannot do by separating variable, right? You can't separate. Okay, but C, I think you need to solve by what we call it, integrating factor. Okay, because this is the first order linear differential equation. So maybe worth to talk about this. So we can rewrite this as y prime minus half y equals to 2 sine 3 theta. Okay, so you can set up what's your pt, what's your qt. Still remember the thing that we taught last lecture? And then try to find what is your integrating factor, which is e to the integral of pt dt. And then you find your solution y. Yt equals to 1 over it, and then integrate it times qt. Okay? Yeah. If I want to write everything down, right? So your solution is this e 1 over e to the integral of pt integrate integral of pt dt times qt dt. So this is your full solution in terms of pt and qt. Okay? Yeah, this is your full solution in terms of pt and qt. Okay, now. Yeah. I think this will be solved similarly. So let's skip this. How about 3 and 4, 5? Or 5 is very similar to what we did last time, huh? Is the concentration of salt. And then number three is a model growth. So this model growth is linear, proportional meaning linear here, proportional. So so this is the model growth. And then 4 is the logistic. Is it logistic? Let's check. Sure. Yeah, it's the logistic model here. Kp times 1 minus p over m. Here m is 1. Okay, how about 3, 4, 5? What do you think? Should we try any of these? 3, 4, 5. Which question that you think that you cannot understand what the question want you to do? 3, 4, 5. Maybe let's try one more, and then we'll discuss quiz. Who want to pick? 3, 4, 5. Maybe pick one from Brandon. Which question you think you cannot understand what the question was? 4. 4? Okay. Okay, let's try 4. So biologists has determined that the maximum number of fruit flies that can be sustained in carefully controlled environment with a limited supply of space and food is 500. So this is the maximum number. It says that it's like our carrying capacity. Okay? Maximum there are 500 inside there. Suppose that the rate at which the population of the colony increases obeys the rule of this logistic equation here, where C is the carrying capacity and Q denote the number of fruit flies in the colony at any time t. Then solve the differential equation. Okay, so I think C here is 500, right? Because it's the maximum number. Okay, carrying capacity means is the maximum number you can get. If we write this down, let me check. Where's the carrying capacity? Yeah, the population level of when it approaches the carrying capacity. So C here is 500. Okay. So we're gonna solve this. dq dt equals to kt of 500 minus q. Okay. To solve this, there are two ways. Okay, one way is you just solve like a normal differential equation, meaning you go and do your separable equation, okay, and then you solve it. You know how to solve this separate equation? You see, this is 1 over 2 factors, right? So what's the integration you need to use here? Integration by partial fraction. Okay, so you need to split into partial fraction here. And you do the calculation. But this is what we done in our class, that how we get this formula. Okay, maybe one thing I need to ask you to do is, if you don't want to calculate from scratch, then you need to memorize this formula. Okay, either you do the partial fraction, get this answer out, or memorize this one. Okay, yeah, okay, does it make sense? Okay, yeah, either you go through this calculation and then get the answer, okay, we accept, or you can memorize this, use this formula, we also accept. Both accept. It's not hard also if you do this partial fraction. You see, it's not hard as well. Yeah. So either way will works. So let's say we go through all this partial fraction and then we get this formula. Okay, so we just apply this formula. So what we need in this formula is this A thing and M. So it's the carrying capacity. We already know it's 500. Okay. Yeah. So let's find A now. So I mean, to use this formula, make sure you write it in this form first. Okay. Let's see. Okay, so we need to keep into this form. So you need to be careful. If you're gonna use the formula, you need to make sure you start with the right form. Okay, something times P times 1 minus P over the carrying capacity. But our form is not in this form yet, right? So if you want to use formula, make sure you keep it in the right form, meaning you need to write it as 500 KQ times 1 minus Q over 500. Okay, so you can note that your K in the formula become 500K in this question. Need to be careful. Because if you're gonna just do integration, right, you will take account this thing already. Okay, if you just compute by hand, then you can get this. But if you use formula, make sure you need to stay in this form. So you need to keep your P outside, 1P outside, and then keep this 1 here, and then keep this P here. So the other thing could change. Okay? All right. So now let's use this formula. So PT. So let's find A. What's A? A is the carrying capacity minus the initial one, and then take division over the initial. So A will be 500. What's the initial number? A. Why there's no initial one? Okay. So in this case here, in part A, you are still not given the initial yet. So what to do? Leave it like that. Okay, just leave it as a variable. Does it make sense? In part A, there's no initial population yet. Okay, so in this case here, your solution will be just PT equals to 500 over 1 plus A. So 500 minus P naught over P naught times e to the KT. So e to the minus, our K become a 500K already. So here e to the minus 500 kt like that. Okay. Make sense? Question? Any question? Okay. Yeah. So in 4a here, hey, Brandon disappear. Brandon go toilet. Okay. So for 4a here, your P naught is not determined yet. Don't know what is P naught. So you just left your answer with P naught. Does it make sense? Okay, so far. So there are actually two variable appears here. I mean, two constant that appears here, which is P naught and K. It's not determined yet. So you can notice that in the second part, it tells you what is P naught. Okay? And then it tells you another number so that you can find the. Okay, after that, then ask you to find what happens in the 50 day. Okay, after they tell you the two constant, only then you can figure out population at different time. Make sense? Okay, Brandon. So for the part 4a, we can't have P naught yet. There's no P naught. So just leave your answer as in terms of P naught, K, and T. Okay, let's work out the second part here. So from A, we know that PT equals to 500 over 1 plus 500 minus P naught over P naught times e to the minus 500 kt. So since we know that P naught equals to 20, then PT will become 500 over 1 plus 500 minus 20 is 480. 480 divided by 20 is 24. Okay, 24 times e to the minus 500 kt. Okay, we still don't know k yet. Okay, but we know that, or given that e of 20 is 35. Okay, so we need to solve this. 35 equals to 500 of 1 plus 24 e to the minus 500 k times 20. Yep. Okay, so solve this. So please calculate what's this. 35 over 100, 500 minus 1 over divide by 24. And then, hey, sorry, do the other way around. So 500 need to be divided by 35 minus 1 divide by 1 over divide by 24, taking ln, correct, right? Yeah, taking ln and then divide by 10. How many 0? 1, 2, 3, 4. 1, 2, 3, 4. So this is your k. Can you check? Is this right? Your k is hiding inside the ln. The k is hiding inside the ln, right? So you multiply the denominator across, divide by 35, and then take away 1, take away, so divide by 24. And then you want to find something inside the ln, you add something inside the exponent, you take a ln. So this thing go down, and then you divide by this minus 500, this one. Okay? Correct, huh? What's this? What's this? Let's use apple note. Can Felicia read out the expression again? Minus 1 over, and then ln. Ln what? Okay. Yeah, 1/24. Multiply. Multiply by. Mm-hmm. 20. 35. Okay. And then -1. Okay, what's this? My Apple not decided not to read this. Oh, okay, coming up. Correct. So 0.000. Why can't I? Hmm. 0.00422? Is it? 0.00422. Okay. Yeah. So our PT is 500 over 1 plus 24 e to the 0.00522, 0.00522 multiply by 500, you get 21.1 e and then negative. Okay. So how about we want it to be in 50 days, right? So hence T50 is equals to 500 over 1 plus 24 e to the minus 21.1 times 50. So what's this answer? 5, 5, 10. Okay, so let's calculate 500 over 1 plus, let's see, 24 e to the minus 1055. So what's this number here? So, 500. You reach the maximum. Yeah, we reach the maximum. Is it? So the question is round to the nearest integer. Maybe you should pick more decimal here. Maybe pick more decimal. Maybe pick more decimal. Yeah. And then you can see that actually it kind of reached maximum. Is this true? Hopefully it's true. Meaning it go pretty fast, huh? If this is true, let's say this is true, then it grow pretty fast. Okay, you start with 20 fruit flies in the first day. After 20 days, it just have 35 or 35 of them. But then you double up the day, it will fully like occupy the space. If the calculation is correct. Okay, maybe you can try and check the calculation again. Okay. So far, any question on this step here? If not, maybe you should check the calculation. If the calculation is not wrong, it says that you double up the day, right? Then you can already reach the maximum capacity. Okay. Yeah. Try check the step, is it correct? I'm worried that the step is wrong. Almost every time I did differential equation, I calculate wrong. Especially the how many zero you use is very important. The zero matters here. Okay, so far any question? Question so far? Question? Yeah, how are you? Okay or not? Okay. All right. So if no question, then we will jump straight to quiz 4 here. I think quiz 4, I guess everyone is doing okay, but just to make sure that we are on the same page. Where's my quiz for? Okay, here. Okay, so for the first question, I think you all are knowing very well that you want to do substitution on ln x because you know that the difference is there. The derivative of ln x is 1 over x, so 1 over x is there. Okay, so after that, what you need to do, the bottom part, it is a quadratic, but then you realize that you can factorize it. So after you factorize it, you should use the partial fraction to solve it. But then please remember, for the ln, right, you need to put absolute value. Okay, please remember, unless you know the condition that maybe the thing inside the absolute value have to be positive, then you can throw it away. Okay. Yeah, you have to use absolute. This is what we proved last time, right? If you remember, derivative of 1 over x is a derivative of ln x is 1 over x. And then plus c, most importantly, plus a constant. If you still remember, right, because antiderivative, you can add any constant to it. After you differentiate, it disappears. So there is an extra thing coming up. Depend on what's your value taking. 2 is improper integral. This one very straightforward. Oh, these two you see, same technique. Or did you realize? Did you realize same technique? So that's why you think it's easy, huh? Because it's the same technique. Other than that, I think it's very straightforward calculation. Ln m, when m go to infinity, is going to infinity. So you divide by a very big number, so you get to 0. 3. Okay, part 3 also kind of straightforward, maybe a bit tricky where we put a 9 in front of x squared, but this is a very similar question to your lecture notes. Okay, so instead of setting x equal, just set x to a over tangent theta, but the a here is a fraction now. Okay, or you set 3x equals to 2 sine theta. I think a lot of you stopped before the last step here, but I gave you full marks. I think it should be fine, right? You are not stopping here. You are not stopping here, but you at least substitute in your x's. Okay, but if you stop here, definitely you will lose mark. Okay, if you stop here, you will definitely lose mark. Make sure when you integrate with respect to x, your final answer should be in terms of x as well. Okay, don't stop at the substitution step. And then the last one, I think quite straightforward, but I think someone miscalculate or they miscalculate the derivative. That's it. You see, for this question, you don't even need to know how the curve looks like. You can apply formula already. Can you see that this curve actually is quite complicated because there's one term that is not differentiable at, not defined at 0, but we already missed that part. We don't integrate there. Okay, we integrate where this function is defined. Yeah. Any question for quiz 1? No, very easy. What score you get? 19. Wow. Is it the highest so far for the quizzes? I think so. Okay, good. How about the rest? Okay, with this quiz here. No, no question. Good. Any more last question? Last question. Maybe it can be exam related. How to prepare or what? Yes. You cannot take formula sheet, but we will provide important formula for you. Okay, but for the solution, for differential equation, I guess you need to memorize. I don't think it's in the formula sheet. Let me see. Let me check. Wait, let me check something. I think we will give like the trigo stuff, but then yeah, we don't give you the differential equation solution. Either you work it out on the spot or you memorize it. Because it's using the partial fraction to calculate. So it should be workable. Any other question? Any other question? If no question, how about we take a group photo? Okay, to end our semester. Yeah. Thank you for this semester. Yeah. Hey, can we have Chen Fan friends to help us to take the photo? Okay, ask your friend to help. I think she's always in our class, right? I realized. Yeah. Maybe everyone just sit here. Just sit at your space and then see if we can capture everyone. If not, maybe some of you need to squeeze to the middle. Yeah, maybe starting from Wei Ye. Maybe everyone here need to go into the middle. Maybe yeah. Maybe from Wei Ye. Yeah. Here. Move into the middle. You can left your stuff there first. Maybe Felicia can move to the right. And then three of you. Maybe three of you move in. Then should be fine, I guess. People at the back maybe can stand up. People at the back. Okay.
全部人都
Yeah, okay. Maybe Madia also move in so that we can make the camera a bit larger. Maybe Jose, you move here. Yeah, yeah, yeah. Yeah, you can go. Okay, so make sure 哪里一的是耶的过来耶的可以尽量越大越好。Okay. Yeah, India, you hide behind people. So make sure you get your faces out. Okay. 如果 OK，你就1、2、3。
哦。
Okay, wait for the cue 啊。
1、2、3，起来字。OK。
Okay. Okay, thank you guys. Good luck in your finals. Okay, if you have any problem, you can message me. Thank you. No.